Hi everyone, welcome to this new session of Additive Talks. If you are joining us for the first time, make yourself comfortable. Additive Talks is simply a series of panels that focus on discussing the use of additive manufacturing technologies in a given industry. If you have been here before, thank you for listening to our insight into the world of AM. My name is Katie Sinze, Managing Editor at 3D Additive Media. And without further ado, I would like to give the floor to our experts so that they can quickly introduce themselves as well as the company they represent. And I will start with Stephanie.
Hi, hello. Yeah, thank you for having me. And I'm in here now maybe in two roles. One of that is being head of additive manufacturing at the German railway company Deutsche Bahn, which is the leading rail company in Europe. And when we started with additive manufacturing, which is now 9 years ago, we thought about getting into contact with other companies and not to undergo the same learning curves. And we were looking for a network, didn't find an appropriate one, and founded our own one. And that was the start of mobility, and meanwhile also medical goes additive. And that has now become a very big network with 150 member companies throughout Europe. And there we try to work on those subjects one company cannot solve on its own.
Well, thanks, Stephanie. What about you, AJ? The only one in the US.
Right, I'm the one with the funny accent on this call, that's for sure. My name is AJ Strandquist. I'm the CEO at Worth Additive Group. That's a startup company of the larger Worth Group. And similarly, about 8 years ago, we had customers that were having line down issues, that were having service disruption to their end clients. And a few of us got together and said, well, maybe we should make these, right? Because we knew 3D printing was an option. And it started with those simple parts almost a decade ago to where we're an international team building a digital inventory service network to help roll out those parts in a controlled way. So very excited to be here, and the dialogue, I'm sure, will be great.
Thank you very much, AJ. And Christian, last but not least.
Thank you, Katie. Thanks for having me here. My name is Christian Ochs. I'm working for Siemens Mobility. This is the railway division of Siemens. And I'm the head of additive manufacturing there. So running our additive business on now 14 locations. What is Siemens Mobility to the ones who know Siemens, but not Siemens Mobility? We are a railway company. So we build trains like this nice guy here for Amtrak in the USA. But we also do a lot for rail infrastructure, especially the intelligence to let the trains run on the tracks with close distance and stuff like that. We do, of course, service for our customers, so they can contract with us a service contract, for example, for 30 years, and then we guarantee them 100% availability to be able to drive the schedule they intended. And we do big turnkey projects like bringing a railway system to a country where nowadays there is none, like we do it at the moment in Egypt, for example. So very interesting business, and very happy to be here and discuss with you.
Well, thanks. We are all happy to have you around this virtual table. A quick reminder for the audience, if you have any questions, any remarks, please use the Q&A chat, in front of you, and then we'll publish it at some point during the conversation. We'll pause and let the speakers, answer any questions you have. So today's discussion is about going beyond the use of AM across the spare parts industry to focus on strategic steps that can make such a business successful. And before we dive into this topic, my first question, just to introduce, the subject, is for Stephanie. The spare parts business is a multi-billion-dollar, industry. Opportunity across the world. And for analysts, some segments are more relevant for AM than others. According to you, Stephanie, and given the extensive expertise of DB in AM and your role, at MGA, what makes the railway industry an interesting case study for additive manufacturing?
So, yeah, I mean, it's an enormously interesting sector for additive manufacturing. And that is because we just have very low numbers, yeah, compared to automotive or other mass series production items or products. We usually do not have that many parts which are needed. So when we started our activities in the rail, we were focusing on printing spare parts. Sometimes we really have the problem that we can't get our hands on spare parts anymore. And if we do so, then we have huge minimum order quantities. And so it's really a huge problem getting those spare parts, bringing those trains back on tracks, or even refurbishing the infrastructure, which is also in our focus. And now we have a great solution with additive manufacturing to print those parts in small numbers when we really need them. And this is why additive manufacturing comes in. So we are not a construction company like, for instance, Siemens. We reproduce parts. And this is why we also have to stick with form, fit, function, not to lose our certification for those products and spare parts. And this is why we focus on a very specific sector, which is obsolescence management at the moment. And nevertheless, even if we don't do bionic designs and functional integration, because we're not allowed to, it's still a very, very good solution if you have high numbers of spare parts you have to put on stock. Just to give you an idea, at the moment we have spare parts on stock just for the rolling stock part worth 1.2 billion euros a year. That's really a huge number.
Yeah.
And we talk with our colleagues from, for instance, Siemens and also Alstom, and we are quite sure that we could print 10% of that already today. We don't do it for specific reasons. We're going to talk about that, I'm sure. But that could be a great solution.
Okay, good. Well, Christian, you mentioned during your introduction that you're a railway company, and I thought that Siemens Mobility has a wide range of services, and I wanted to ask, what is the key segment that's related to spare parts manufacturing, and that can benefit from additive manufacturing?
Yeah. Trying to make the link to what Stephanie said.
Yes.
I would say the rolling stock segment.
Okay.
For those who are not from the railway business, the rolling stock is more or less the segment where the trains are built and operated. And there we are using additive manufacturing a lot. We started more than 10 years ago also with the spare parts use case because it makes so much sense. And nowadays we are also implemented it in our development processes for new vehicles. And this is, by the way, also necessary to reach a higher amount of additive parts and to use the benefits additive can give us to the full extent. Because, as Stephanie explained, for the spare parts, we have to fit to form, fit, function. So we cannot change too much. Even if we are already changing a lot when we switch a conventional part to additive, because we have a new production technology, because we print it, we sometimes use new materials. And so we change a lot and we have to release that to still comply with the regulations and to make sure that the train is running safely.
Okay, good.
And of course, we are also trying to use it in the other segments like the rail infrastructure. But there, the problems with obsolescence are not as big as in the rolling stock sometimes. And these vehicles here, they are designed in the beginning for 30 years of usage, but often they are in operation much longer. The oldest train I saw was more than 70 years old, and so much older than us. And so you can imagine when you have such an old train, you do not have any digital files.
Yeah.
And sometimes you do not have the suppliers anymore. So it makes it really challenging to get to the parts when you then need it. And I think, Stephanie, you can confirm that, right?
Oh, absolutely. Yeah. So, we're dealing with very old trains and infrastructure. We are also dealing with quite new ones. Yeah. So we have the big spread, and at Deutsche Bahn we use in AM 12 different technologies in AM. Yeah. So to tackle all those different fields and. So this is very specific, maybe also about the rail industry, that we have such a broad range.
Oh, and I would like to hear a little bit about the technical side of this topic, and AJ, what led a company like World Group to pivot its AM division's business model towards digital inventory?
Sure. And honestly, so I'm used to supporting railway cars,
Okay.
bicycles, car seats, whatever. We sell production goods, right? We're an industrial supplier. And similarly, if it goes into a train, they already hit on the quality control, the quality assurance required, the deviations required if you want to change a part spec. And that's extremely difficult because they're extremely ingrained. And I think, as Christian put, it's an industry standard. So as we went to support those folks, the way Additive was running is there wasn't a good way to keep track of quality control and quality assurance on a single part, right? So the word thesis is we're used to buying 50,000 of a part. We test 10 of them. And now the 49,900, we give a thumbs up. But now we might have 50,000 individual quality reports.
Oh.
And so as you think about that, it's required if you want to have parts out in the field, because they mentioned there's crashes, there's mistakes, there's lawsuits, there's all this stuff that as Worth we're used to supplying, and then you have to do a bit of a investigation, right?
Yeah.
Why did it fail? What failed? Then you do an autopsy on the part. Was it built the right way? Was it not? Was it a design failure? And so really, as we came up, is to tie back into the theme, is we had to control it. And as we looked at supporting parts from the past, they all had a defined process of how to get made, right? And so as you go to switch to additive, there's a lot of red tape, and getting that deviation, especially on a part that's 80 years old, or a train that's 70 years old, that's extremely difficult because some of those parts may not even be available, as they mentioned. So there's kind of two worlds that we live in to support and bring this together. Is one is when you look to history, we do our best to support those parts, and how do you bring them digital? But as I think Stephanie and Christian can kind of elaborate on later, it's really putting a strategy going forward with your new parts and development, with your new products coming to market, and how are you going to have those digital backups ready, where maybe you use traditional manufacturing for the production run, but you have the backup file that you've already printed and tested in your normal product, acceptance test. Now you can go ahead and have legitimate parts saved on a hard drive going into the future. So in short answer, the reason why Worth got into digital inventory is there wasn't a good way for these parts to go out into the world in a way that we were used to account for all the liabilities and quality assurances necessary.
Yeah, when we talk about digital inventory, usually we are talking about, as you said, AJ, parts that are sent across the world. And for instance, Stephanie, Deutsche Bahn may be headquartered in Germany, but has different subsidiaries across the world. Do you think that the different regional norms that exist in the sector present a set of challenges for additive manufacturing? If yes, what are they? The question is also valid for Christian, but I would like to hear Stephanie first on this topic.
Yeah, so Deutsche Bahn in the rail sector is just present in Europe. So there we have the, you could say, advantage that we have the same norms we have to fulfill. But those norms can be also very struggling. And like, for instance, flame retardancy plays a big role in rail, and that level is even higher than in aviation. And this is really interesting to follow those high levels of quality which we have to fulfill. And therefore, we needed also very good exchange and communication with the AM industry. Because when we started, those materials did not exist. Meanwhile, we have a broader range. And this is really cool that we can also tackle those questions in the network, and to say we need some specific materials, we need norms, we need standards for education. And then the whole industry can answer to that. And this is what really helps companies like Deutsche Bahn, but also others, to get more into additive manufacturing and even fulfill standards of different countries. So you asked for like a global approach. That is more with our DB Schenker colleagues. Schenker, the logistics company, is 100% daughter of Deutsche Bahn, so they have more the global approach. But I think it's also a very interesting question, since, for instance, Christian has to deal with that even more, and you can see in the background, unfortunately, it's not a Deutsche Bahn train, it's an Amtrak train. But there you can see he's building
Don't be
trains for
bad.
Deutsche Bahn, for other railway
Let Amtrak
companies.
have its moment, okay? It's not very popular, so we need to let it have a moment.
And AJ, you're absolutely right. So I went with an Amtrak train last time I visited Boston, and it was a very good experience. Yeah. So, but the problem is more on the side of Christian. In the network, just to answer that shortly, we have 7 European railway companies, and they all have to deal with like very similar challenges concerning norms and standards. And all of them want to reduce, on the one hand, in their own maintenance sites, but also want to rely on printing service bureaus. And this is why we need not just a physical network like MGA, but also a virtual network.
So Christian, yeah, we are listening to you.
Yeah, thank you. So I would confirm that the different standards that we have worldwide in the railway business are a challenge. Of course they are, and that's also why I put an Amtrak train here, Stephanie, to show that we deliver worldwide, and there in the US we have slightly different regulations and standards than in Europe. But of course, flame retardancy as one very, very prominent example, especially for 3D printed polymer parts, is a crucial thing. But it is slightly different, and so are the release processes. So when we produce for the American market, we have to adapt to that accordingly. But as we are talking a lot about additive today, let me add that in the additive world, we have still the same issue, or we have 2 issues. One issue is that we do not have enough standards and regulations yet, especially not for all the existing technologies on the market, to be able to really design and calculate and release industrial quality parts according to these standards. And of course, German, European, American, and other standards established already, or are about to establish. And that's why it's very important to work closely together. And that's why networks like Mobility Goes Additive are so important, where we try to bring all the players together. Also the ISO ASTM working groups, where one of my senior experts, Maximilian Kunkel, participated last week in the US to harmonize these norms, to align on worldwide. What we need is so important. So important, especially when we look at that topic long term. And I think we are looking at it long term because these vehicles are so long in use. And that's the reason why working on such a topic is so important, but takes time and energy.
Yeah. And AJ, how can AM users, how can AM users transition to a digital inventory business models? What, according to you, what will be the key steps to consider this path?
Maybe I'm simple in that way, but does it help your company make or save money? Right. So as we look at it, we have one customer or one client that's actually doing that strategy. Is they sell automotive clips. It's called IMS. And they make automotive clips when they've been making them for 40 or 50 years, where there's 40,000 that they have IP for, they developed it, they have all the information, but they keep 5,000 in stock, right? So what we help do is, one is we help digitize those products and prove that the mechanical function is the same or better. But really, the reason why they're investing is because they have money to be made. They looked over the past 3 or 4 years of what on those inactive articles had demand. And they're looking at that as not only could they capture that demand, but it doesn't have, I think Stephanie mentioned it earlier, when you have minimum order quantities, when you have production runs, when you have to tool up a line that for an unpopular part, people don't like doing that. But if you can make that small quantity on demand at a premium, all of a sudden, the things that made those inactive articles not attractive, because you have the carrying costs and all those other things, now it is attractive because you got rid of the money on the shelf, right? And so companies should look at the dollars first, because 3D printing has a lot of advantages, but you have to prove that the investment in digitizing a part, looking back in history to reverse engineer parts and make them in, it's a labor intensive, especially going backwards in time, where there should be a monetary benefit. And what I think the world we really want to get into is, during a product life cycle, additive is always part of the ecosystem.
Yeah.
As a product's in development, they keep that in mind when they put that tractor out in the field for their testing. They have the mass manufactured part as well as a 3D alternative on the tractor, so that when they get their field testing done, both versions of that part get a thumbs up. And now we get to look into the future business case where there is no sunk cost. You're not trying to get parts that weren't designed for additive to be printed. So we really it is a world of two things. Are you looking in the past and trying to bring things that weren't meant for additive into it, versus are you looking into the future, keeping additive in mind with your product development?
Yeah. Thanks, AJ. Christian, if you can share a little bit of your secrets with us, what are the existing challenges, Siemens Mobility might face in, its digital supply chain business? I mean, how does your digital supply chain business model look like?
So then let me start explaining how it looks like at the moment. So everything starts with the customer, and I totally agree to what AJ said.
Yeah, definitely.
It's important to create something that generates benefits for the customers, be it cost-wise, be it time, or just to make it easy. And that's how we started, and that's why we implemented a marketplace for railway spare parts, where you can check mymobase.com, everybody of you in the call. And there you will find hundreds of thousands of conventional spare parts, but also additive spare parts we placed there. So our customers, for which we redesigned these spare parts in the additive way, can reorder them there more or less as easy as on Amazon. And if they make a special contract with us, they get them delivered Amazon-like within 24 hours. So this is more or less what we established, and we have in our digital warehouse right now more than 3,000 part numbers that we have redesigned and produced at least once per part, but some of them more than once, and delivered to the customers. And there are serial parts among them, like this one, but there are also a lot of spare parts. And we are producing them in our certified printer network. Certified means the production process is certified by an independent body. In Germany, we have the TÜV, for example, who is very prominent and who is doing it at our end. So we can guarantee that on every printer, we are able to produce really reliably the same quality level, which is needed for these industrial applications. So this is more or less how we set it up. And now when we go to the future, we want to open it up for our customers, like Amtrak or the Deutsche Bahn, and bring them also into our network, both on the printer side, but also on this digital warehouse and inventory side. And then there are some challenges that we have to deal with. There are these IP aspects, who owns the IP, who is legal aspects, like who is responsible for for the quality of the part in the end. When you have, for example, one company, Siemens, for instance, that has done the designing of the part, then you have somebody who is doing the digital platform and maintaining that, and then a third party is downloading a file, putting it on a printer at their location, and then printing it out. And then in the end, the quality has to be according to what was intended, to say it that way. And in every of these steps, there can happen something, more or less, if you do not set it up the right way. So this is legal aspects, IT aspects, quality aspects. These are still challenges that we are working on. And of course, everybody also wants to earn maybe money with that. So you have to ensure that if somebody downloads it from the digital warehouse and wants to print it one time and buys a license for one time, that it just can be printed one time and only by that party that downloaded it, and cannot be copied 100 times and printed by others.
Okay, good. And maybe just one last question for Stephanie before we pause to answer the questions from the audience. Stephanie, can you please elaborate on a couple of critical issues to tackle in the digital supply chain for 3D printed parts, maybe taking a couple of examples from DB, and then we'll move to the questions from the audience. Just a couple of critical issues you think we absolutely need to address.
Okay, so what is really crucial in AM is that we need more materials, we need more standards. This is what we've already talked about. Prices are still a bit high. I know that all those machining producers are working constantly on decreasing the prices of material and especially also the technologies. So I think we are now on a very interesting level because it's becoming more and more efficient, and costs can be much more compared to traditional technologies than a couple of years ago. So it's all going in the right direction, but still we have all to work on those. And there are some specific questions, as I said before, one company cannot solve on its own. And then it makes really a lot of sense to do this in a joint approach. And I definitely think that that additive manufacturing is one of the most important future technologies. Yeah, and many people say it will only be a niche technology. I doubt that. Maybe not in the next 5 years, but after that, it will make such a big impact on not just rail. Yeah, we are talking about rail today mainly, but on so many others. And if you think just about binded capital, that's so crucial. If you think about sustainability, there is no technology which is as sustainable as additive manufacturing. You can save time, you can save molds, you can save costs, and you can also save a lot of material. And this material aspect will be really crucial in the future, since the raw materials are getting more and more critical at the moment, also on a global political level, which has nothing to do with additive manufacturing. But additive manufacturing is one of the answers to that. And this is why I'm absolutely positive and enthusiastic that we will see in the upcoming years a totally change in the perception of AM.
Okay, thanks, Stephanie. Let's try to answer in a couple of questions from the audience. The first one is from Robin. I research in the field of additive manufacturing and repairs spare parts. In my study, one major barrier appeared to be the lack of AM consideration during product design and development stages. What is your take on this, and how can we prepare AM usage for spare parts in the beginning of product development? Yeah, Stephanie?
That can only be driven by big OEMs. to be honest.
Okay.
Yeah? So this is what we've done now as Deutsche Bahn, and Deutsche Bahn was not the first railway company who did this. Those were the Dutch colleagues from NS. And what we did now is we put into the tenders for the next train, high-speed train generation, the 10% of the parts have to be printable. And I think this is really crucial. And now, I mean, Siemens and also others, they are very experienced in using additive manufacturing. So Christian is a real expert. It's nothing new to him. But it's not him alone. It's the whole supply chain with the second and third tier suppliers who have to help those big companies like Siemens. And some of them haven't even heard about additive manufacturing. We constantly have talks with companies who ask us, can one still really print in metal? As being in this technology now for a couple of years, you're sometimes surprised that the knowledge is not there yet. But this is how we have to push the whole industry. And if you put this in tenders, then the whole industry has to follow. And it saves a lot of costs throughout the whole supply chain in the future.
I don't know if AJ or Christian want to add something before we move forward.
If it's okay, Christian, just because I'll forget if you go first, is to Stephanie brought up two key points, in my opinion. Number one is a very simple thing, which is it all starts at the buy. We say, okay. So her point of going to because let's just do the logical thought process is Deutsche Bahn comes to you and says, I'm looking to shop for my next generation of trains. Wow. Bunch of companies are excited, right? And then they go, 10% or 15% of my parts have to have this backup. And now every company's going to do it because they want that next train. So I think that capitalism helps move this conversation forward. But if you go, okay, capitalism took place and they're going to start to make 10% of their parts, that's when you have to make sure that that company is educated across departments, engineering, purchasing, operations, because each one of them interact with that part normally, whether it was additive or not. An engineer is going to engineer it, but other people have to buy it. Other people have to pick it up. Other people have to, process, do secondary processes, what have you. And so really it's adding this new delivery method, this new production method into your everyday process. And because it's an everyday process, essentially every department has to understand the benefit. If purchasing sees a higher price, like Stephanie said, what is their incentive to just pay more for a part? Yeah. It has to be that there's no minimum orders, that the availability is 100%, these other things. And now a purchaser doesn't want to fight a price point that they see. They go, well, I just got rid of a vendor, for instance. That's a benefit because that's less to manage. So I only wanted to say is I think starting at the buy is 100% right. But if you're going to start to integrate those parts, it has to start at product development and go through that entire chain. Even if you're going to use a mass production method in between, you still need to use additive throughout your qualification time, or that part will have the exact same issue that they mentioned earlier, which is it's not validated and you're going to have to do all this work over again.
Thanks, AJ.
Yeah, thanks, AJ, for bringing the buy point, because I think this is very valid. And as an additive guy, of course, we are happy that Deutsche Bahn now put it into the tender. And I think what is very important, AJ, you mentioned it already in one sentence, is education. So knowledge. Additive manufacturing is a very capable tool, production technology, besides other production technologies. I'm a production guy. I was working in production for 15 years now, and most of that time in conventional manufacturing. So I love conventional manufacturing, and these technologies are great. But additive is great as well. But there are a lot of designers out there who studied 20 years ago, 30 years ago. At that time, additive manufacturing was just good for samples or something like that. Nowadays, we can make rock solid metal parts out of additive. No problem. Also polymer parts. And the designers need to know that. And I'm coming back to the question that was raised, because of course, to use the full benefits of additive, you have to focus not just on a spare part and think about, can I print this conventional part additively? Because then you will always realize this part was originally designed for turning or casting.
Yeah.
And when you studied mechanical engineering, design for manufacturing was key. And when you design something as a turning part, turning will be the best production technology, the cheapest, the best quality for that part.
Yeah.
And when you want to do it with another technology, it will get more expensive.
Yeah.
That's it. Yeah, it's possible sometimes, but it will get more expensive. So we have to stop just looking this part view and go to the functional view.
Yeah.
Look at a group of parts. What function are these group of parts fulfilling? And then do, as we additive guy call it, a functional integration. And then we can create a additive part which covers maybe more complexity, but we can do it at a cheaper cost level. And then, AJ, we are again at the buy point, and then we can get to a better or an advantage even on the part level. But I would strongly recommend not just look on part prices, but look on life cycle costs. Especially when we talk about investment goods, like machines, or like railway systems, like trains. They are investment goods, and so the buy-in is just one aspect. Keeping it in operation 30, 40, 50 years also consumes a lot of money. And when I consider additive as a tool for serial production, maybe, if it's really beneficial on the part level. But later on in the usage of the trains, when the quantities of the spare parts are getting down, as Stephanie explained, the quantities are not so high, then additive might have a big advantage, especially over tool-dependent technology like casting, from the cost side. And if you focus on life cycle costs and you have design for manufacturing and design for additive in mind right from the beginning, I'm sure you can create on the functional side and on the cost side better trains.
Thanks, Christian. We have 20 minutes left to answer a lot of questions, so I'm going to ask you to be a little bit brave for the rest of the questions, and I will move to the next question from Robin, because she's asking a very important question, I believe, for this topic regarding legal issues. What role do legal issues play in practice, e.g. regarding liability or IP rights? When does it make sense that the user or operator, for instance, DB or the OEM, for instance, Siemens, prints spare parts with AM? Who should do it? And I would like to ask AJ to answer first, because I know you worked Additive recently launched a digital inventory service, and I'm very curious to hear more about this legal issue aspect on this topic.
It's everything.
Okay.
So what shocked me going into the industry is I'm used to having pre-production approval process or a spec to follow for a part. And you're supposed to follow that spec. And if you follow it, you did your job.
Okay.
And additive really didn't have much functionality to help you keep track of it and protect yourself, either as the person installing that part on the train, the person making that part, or the person that designed it. We have three players really, and there could be more, but who designed the file? Because if that part breaks 1,000 times, it might not be the manufacturing method. It might be the design was bad.
Okay.
Conversely, if you have one part break and you can take the part, right? You have to do a bit of an autopsy to understand what happened in this collision or whatever. And you're going to see that part, when you slice it, they didn't use 316 stainless.
Okay.
They might have told you they used that metal, but when you actually find the part, it wasn't, and that's why it failed. So the producer of the part is now in charge. Conversely, everything was right. The person installed it wrong. It was bolted upside down. The installer is the person at risk.
Okay.
And so really, you're never going to get away from people having to own liability when you're putting a part, for instance, on a train. Because the government and other people want to protect the public from someone just throwing a bad part, it breaking, and someone gets hurt. And so honestly, the legal part is gigantic, because if you don't have a track and trace and an ability to manage these parts out in the world, no company wants that exposure, because if you're putting parts that are unrefined, not validated, don't follow a traditional PPAP process or quality control process, you're at fault, no one else. You're not doing your due diligence, right? So I think it's absolutely massive in why additive has had problems with adoption is there's been hundreds of years of manufacturing knowledge, and just like they mentioned, maturity. Additive is extremely immature in some of those processes, but it brings so much benefit. The question is how can we get it into those processes and those norms as soon as possible so that customers and people can feel comfortable using it, because they have all the same liability assurances and protections that they would have in a normal part. Yeah. From my part as a helping support people in the program, that's what I think is a huge hurdle.
Okay. Stephanie, do you have a different take on these questions? Because I know, you're a user, so I don't know if you have some sort of, responsibility on these legal issues.
So first of all, additive manufacturing is on the market now for 30 years, but still in those really critical technologies, which are also the game changers, the technology is not that old. And therefore, it's exactly what AJ just mentioned. We have to feel really comfortable with what we are doing. And as a railway company, we put spare parts on trains, also mobility critical or safety relevant spare parts, by the way. And in those trains, we have hundreds of people. So we have to be absolutely sure that those spare parts, and we are not just talking about hook hangers, really will not fail. They will succeed. And therefore, we do a lot of testing. If you do a lot of testing, it's necessary, but it's also expensive. Okay. So therefore, we need those standards that we can really rely on technologies, materials, and whatsoever. Yeah. And this is what we are doing at the moment in cooperation with a couple of companies, because the advantages are definitely there. So we have to work on that and have to feel more comfortable. And if we put safety relevant spare parts in a train, then you can be sure we've done a lot of testing. Yeah. Okay. And it's also our aim to be definitely on the safe side. And this is also why we've established an auditing system for spare parts producing companies that might be also printing service bureaus, for instance. Yeah, we work with a lot of printing service bureaus. And but there we have to be sure that they also fulfill what we've told them. Yeah. And therefore we established with the TÜV an auditing system. So if any company would like to produce spare parts for us, they have to undergo that. And then we can, of course, be sure that they do the right processes and use the right materials.
Thanks. And from the OEM side, is there a different take on this question, or should we move to another one?
No, there is no different take. I can absolutely confirm what AJ and Stephanie said. Okay. When we talk about spare parts and legal aspects, I like just to add one more aspect.
Yes.
Because we should not forget that the spare part was in the beginning done maybe by a first or second tier supplier in the conventional way. So he has the IP. And when we now want to print it, we have to ask.
Yeah.
Okay.
We have to make sure that it is possible if he does not want to print it by himself, for example. But we from Siemens then have to do it, or Deutsche Bahn does it directly. Yeah. Then we have to take into account that as well.
As Deutsche Bahn, I can also tell you that, of course, we've checked that. And usually we always try to get our parts on a conventional procurement way. Yeah. So just when our procurement colleagues tell us we can't get those parts anymore, they're not available anymore. The previous producer, sometimes they don't even exist anymore. That's also part of the problem. So this is just when additive manufacturing comes into the game. And if those are very complicated, very patent logic parts, we will check this with our patent lawyers before. So that is always done.
Thanks, Stephanie. And I think the next question, is probably for you as well, the one from Eliseo. How can the ecological impact of 3D printed parts be assessed, and what are the qualification essentials? Is it a broad topic to discuss as part of this conversation?
Of course, definitely. So first of all, railway operators consider themselves as the most sustainable transport mode.
Okay.
So they have a big focus on everything which is linked with sustainability in general. Then secondly, there are a lot of European norms now coming, like for instance, the Critical Raw Material Act, but there are also other regulations and laws like the Supply Chain Act and others. And they force any, not just rail, any producing companies into different procedures. So we have to prove where do our materials, our products come from, how they are produced, what kind of materials are those, does maybe children work play any role? And we have to check that. We have to set up auditing systems. We have to also prove that our suppliers fulfill those laws and norms. And this is going on. And even if you're not interested in sustainability, which I can hardly understand, but if not, then you're forced by law. And this is why this is so important, especially for all producing technologies, but also for additive manufacturing. And the big advantage of additive manufacturing is that you use less material. You can produce more locally. You do not have to ship parts around the world. You have so many savings. You can, and this is what the industry is working on at the moment, that you can use more recyclable or even recycled materials. So the shift into more sustainability is going on rapidly at the moment. But of course, you also have to prove that, and you need some established measuring logics. And this is what the industry is working on at the moment, so that we can really prove how much is the energy consumption of a printed part compared to a traditional technology. And this is what we put focus on.
Thanks, Stephanie. Well, being based in the US, and I'm very glad you're here around this virtual table, AJ. I just want to check if you have a different take regarding, this ecological impact of 3D printed parts and the way they are supposed to be, the way they are supposed to be assessed.
So one is, you're right. As an American, I'm not as ingrained in the ecological impact, but the thing that we can tell from our side that we have done studies on is on logistics, right? So Worth is a global distributor. So kind of like if you have those trains in 15 countries, I might be, in Worth, Mongolia, I might be selling you spare parts and chemicals and stuff like that, right? In France and other places. And so as we've looked at this, we've taken data from the Worth world where the point of origin, it gets on a boat, gets to a central warehouse, gets split up and so to me, there's a lot of things around production that it's hard to quantify because you don't always know what the mass produced part, how it was getting made, how clean it was, how energy conscious it was. But what we have really concrete data is how many planes, trains, and automobiles did it take to get this product there? And yes, if the supply chain works perfect, it's somewhat efficient, and additive brings like a 15% benefit. It's not as huge. But as soon as you have an issue, additives ecological impact just shoots through the roof, because you think, I've had people get on a plane with a box of, hardware, because that's the fastest way to get it to that client to fix a line down. How many dolphins did we just hurt by having to get on that plane to deliver a box when it's a complete waste, right? And so to me, that is the soft benefits, the ripple effects that additive will have at scale, is there will be less boxes, there's going to be less, expedites, and there's going to be less dunnage getting these products around the world. And that's where I think as it gains more and more volume, you're just going to see those soft benefits add up more and more, and your company won't have expedite fees and all the CO2 emissions attached to those.
Thanks, AJ. And speaking about production, the next question is from Maximilian, and I think that question is for Christian. What metal alloys are most widely used in AM for the railway spare/obsolete part production? What materials are not available yet?
So what we use at the moment mostly is stainless steel. So the 316L HA mentioned is a prominent one, and aluminum. And of course, to have more material, especially if the material is more or less one by one, the original material would help a lot, to bring additive parts, especially when they are safety relevant or safety critical, faster into the application than we had to do it in the past. So this would be a good point. But maybe let me also add to the previous question and pick one more thought, because it's so important. Sustainability is so important, and HA described it so good. When you're entering a plane with parts just to bring them fast, 10,000 kilometers to another place, to the customer, downloading a file, printing it out there locally, is so much faster, and has such a better ecological footprint than flying around or driving around. That's the one thing. And I see at the moment, of course, challenges to measure the CO2 footprint. Everybody who's dealing with that topic, and I think every bigger company at least is doing it. As Stephanie said, the regulations and the laws are tightening. And we at Siemens, for example, we are developing an ecosystem-based approach called SiGreen that we will also supply to everybody to be able to collect this emission data of conventional, but also additive manufacturing. And we work with a green digital twin software to calculate internally in a life cycle approach, how good are the additive parts compared to the conventional parts. But there we are again on a part per part comparison. And what I think is very important, Stephanie, I think you said it, you have an old car, an old vehicle, old train, you need a casted part. The supplier doesn't exist anymore. So what do you have to do? You have to go to another casting company. You have to order a mold, which is maybe made of metal. And then you have to take a minimum order quantity. But you just need 1 or 5 parts. And the other 100 or 1,000, what do you do with them? In the end, you scrap them. And if you check out these cases and take them into account, there will be no discussion anymore. And then I also do not need to calculate it behind the comma or the dot, because it's clearly on the table which technology is more sustainable.
Thanks, Christian. Moving to the question from Nosha. Data are at the heart of a digital business model. Given the fact that we often have to deal with data management or even the lack of optimized 3D models, How do you address this bottleneck? Does your digital warehouse system rely on digital twin models? And I would like to start with AJ for this one.
And so just can we confirm the question? Is it that, can you rephrase the question? I just want to make sure I answer it correctly.
So I think, if I'm not mistaken, what I understand is that I would just repeat the question first. Data are at the heart of a digital business model. Given the fact that we often have to deal with data management or even the lack of optimized 3D models, how do you address this bottleneck? And then,
Sure.
yes.
And so it is a bottleneck, and it goes back to kind of the earlier conversation is, if you're working at a company that's making stuff today, you've got engineers that are drafting parts.
Okay.
Right. And so as they go and design parts in the future, they need design for additive manufacturing type input to design those parts for not just one manufacturing method, but a couple.
Mm-hmm.
Right. And they're really, I think one thing the MGA is really trying to tackle is the education, because the engineers that are in these large companies like Siemens and like Deutsche Bahn, they're not silly people. They're extremely smart, and they make parts in all sorts of technologies, right? And so really, I think the key is to help train those people to optimize their prints as they're going, because their workflow already dictates they have to have a model, they have to make a test, etc. And so the question just becomes is, how can we educate them that as they're doing their workflow, they optimize the print supports, or maybe they have someone like Siemens or Worth or someone in MGA to help educate them on why you can decrease supports. But that's the number one thing, is this shouldn't be a sidecar to your business. It is your main business. You just have to add this new tool to their toolbox.
And I feel like Stephanie was nodding when you were talking, like she completely agrees with everything, right, Stephanie?
Absolutely. So this is why we're doing in the network this weekend students competition. In cooperation with the Association of German Engineers. But we invite teams throughout Europe from universities to think about a specific challenge. So they deal one weekend with this specific challenge. It's like a hackathon, but using additive manufacturing. And this is how we try to get more people in, and more engineers, but not just engineers. We are looking for diverse teams, because we also need the procurement guys. We need the managers. We need everyone in this digital production logic to think more about additive manufacturing and the potential. But maybe the question also dealt a bit with what do we do with old parts where we do not have 3D printable designs. Yeah? So usually, if we are lucky as an operator, we have 2D designs on paper. Sometimes we do not even have that. And sometimes we do not even know which material was used in the previous part. And so this is what we have to find out. We have to re-engineer those parts. And this is what we are hoping for, is that there will be more software solutions in the future, which you can use, maybe also AI-driven, to bring another buzzword in, to re-engineer those parts, because that takes time, is cost-intensive, and the easier we can do that, the cheaper will be also the printing process in general, and we can enhance the number of printed parts.
Okay, good. Thanks, Stephanie. Christian, do you want to add something?
I totally agree, and I can just say, if the data quality is not there before you can print it, you have to create it, and this sometimes is hard work.
Thanks. I know we are almost reaching the end, so to all those people who are listening to us, I would just like to ask for 15 more minutes, because we still have a lot of questions, and I would not like to stop the conversation just right now. You'll be too weak. And then the next question is actually for AJ, and it's a very long question from Bucket. So Correct
I
me if
think,
I'm wrong.
I think I read the question.
Yeah.
And so what I would say is, Bouquet, is that to me is a huge was a huge hurdle. That's why we in the Worth Group invested a lot to help address it. Is it used to be you would have batch QA QC. That's the way the world worked. And so as we looked at it, that quality report, let's say it cost you 500 euros in the past. I can't have the QA on a single part cost 500 euros when we switch to additive, right? But you still need to have paperwork trail. You still need to have some sort of historical record of how it was made, who made it, and who signed off that they followed the process correctly. And so when we say we want to collect QA reports on those individual prints, it's largely device driven. So what we really advise people is there's some things with in situ monitoring that you brought up. Also with telemetry scans at the end of a print to assure that it's the right size and there's no deviations. And now what we can do is bake into your quality report not only a human being saying this is right, but we can collect the quality report right from the machine and attach it to that print number or order number. And forevermore, you can look at the in situ monitoring report from that exact print, from that exact work order. And so we can do it. Really, it's whatever you need to collect into your data and hold it to be able to say if a part breaks, you can go back for that historical record. You need to be able to flex from a very simple part, and you want that to cost very little to manage in QA. But if it's a part that's in the drivetrain of a locomotive, you're going to have the highest level of quality assurance and quality control that you can have. And so as you look at how to manage these parts, you don't want those critical parts to have the same QA process as a part that costs 50 cents, because then that part for 50 cents is too expensive and you'll never use it, right? So you have to have your QA QC collection match the criticality of the part, just like you do today. A PPAP level 1 offers a lot of flexibility and freedom compared to a level 5 PPAP, where they're telling you to keep track of where the iron ore came from, to Stephanie's point about critical raw materials. On the highest level, I need all of that data. And why would I do that for a 50-cent part? It's just too expensive. So hopefully that answers your question. But as a part goes out into the world on single units, you need to have a work order or a purchase order or a batch number attached to that product in case there's something where you need to do research on it.
Thanks, AJ. Birgit, if you want to have a follow-up, series of questions with AJ, please feel free to reach out to us. We'll share your questions and then share AJ's answers thereafter and publish for everyone, on our online media. So next question very quickly. Besides the qualification issues, where are the bottlenecks in the EM supply chain? Design, printing capacity, materials, or post-processing? And I'm very eager to hear Christian's here. Question from Mike in the Q&A chat.
Yeah, thanks for that question. I would say the biggest bottleneck at the moment is none of them mentioned. It's the performance and cost level of the machine and the materials. Yeah, because to what they are able to do, a lot of the machines are too expensive, which brings up the part costs too high, and also the materials often supplied by the machine manufacturers, their costs are too high. And so the system is stopping itself from growing faster. And as soon as we are able to solve these issues, and I know the whole AM market is working on new technologies for metal, for polymer parts, and improving existing ones. More lasers to powder bed fusion machines as one example, improved software as another example. And working on material costs as well. I was talking to a big steel company a few weeks ago, who now gets in heavily into the business to get the costs down of powder bed fusion materials. And this is these are the most important aspects at the moment, which is stopping additive from growing faster.
Thanks. And I think the next question is also for you, actually. I'm sorry. So Journey is, it actually means the website that you mentioned, Christian, when you talk about digital marketplace and the name of the third party that is certifying. So if you could just repeat for everyone, that would be great.
Yes.
Write it in the Q&A chat.
It's the marketplace is called Mobase. So when you go to mymobase.com, I think that's the address. I'll double check it. Then you will find it.
So while you're looking for the address that you will share in the Q&A chat, I quickly move to the next question. I will be, very quickly, question for you as well. Do you consider yourself as a service bureau?
We are not a standard service bureau.
Okay, good.
We are focusing on railway parts only, and besides just printing, what we do for our customers, if they need it but just for the railway business, we are very much focusing on redesigning parts and doing R&D work to further extend the capabilities usable for the railway industry that additive manufacturing has.
Thanks. And then for the rest of the panelists, I will be interested in who should drive the material characterization cost and A4, the rail OEM, the additive equipment supplier, the material producer, or share the cost? That question is from John.
Mm-hmm.
So capitalism.
Sorry, AJ?
I just maybe I'm too American about it, but it'll change. If you're going to buy 100 machines, make that machine OEM do it. If you have 50 machines, but you're going to sell or buy 20 tons of powder, have the powder OEM do it. Do you want to have the freedom to switch machines and powders at will? Then you should do it. So I think you should look, I don't think there's one solution. Maybe Christian and Stephanie have a different opinion, but I don't think there's one way to attribute that cost. It should be the commercial application, who's getting a main benefit, and then someone should do the work to get that big benefit.
Stephanie?
Yeah. Totally agree. Yeah, I mean, that's the point. If there's a big potential turnover in the future, also the OEM would always consider the material provider to take the costs. If it's just about a few parts, then one has to discuss.
And this is where a buyer in your corporation could help, right? They're trained on leveraging interest and demand against a better price or a better service. So just goes back to the conversation about how numerous parts of your enterprise have to take place to make this happen at an efficient level.
Okay, thanks.
So from my point of view, when we talk about material characterization, it's clear that it should be done by the material producer in the first step, and in the second step by the equipment supplier, so the producer and seller of the machine, who is normally releasing then a data sheet what a particular material can achieve on his machine. And because if you want to do it the other way around, so that a rail OEM or an automotive OEM is doing it, he most likely will not release the data sheet. So it has to be done multiple times, and this is not efficient. And I think in every other industry, it also works that way, that general characterization is done by a material supplier, and then the specific characterization, what's possible in the specific process on the particular machine, this is done by the equipment supplier.
Thanks, Christian. And I think I missed one question that was meant for Stephanie. DB relies on external providers to produce parts. What criteria are assessed to ensure they are compliant for railway applications? And I will conclude with that one. I will let you answer that questions before we jump to the conclusion.
Yeah, coming back to what I said before, so if we're talking about spare parts for rail, then we ask those companies to undergo an auditing that can be done by the TÜV, but also others, following a norm.
Mm-hmm.
And so we have to make sure that they are capable of what they intend to produce.
Mm-hmm.
And when I started with additive manufacturing and you were in talks with AM service bureaus, everyone told you we can do anything, which is totally rubbish. Yeah. So if you're always focused on architecture models, you do not have any clue what it means to produce a spare part, especially not in rail. And this is why we try to find out who's capable of doing what. And there are, meanwhile, and we are very grateful for that, great printing service bureaus, and every printing service bureaus usually also has a specific focus, which is good, because I just counted it a couple of months ago. We have now more than 50 different technologies in AM. 50. No one can tell me that a printing service company can do all of them. And so this is how we try to pick the right ones. And yes, the more they're experienced with our sector, the better it is, of course.
Okay, thanks, Tiffany. Well, I think that we'll have to end the session right here. Thank you, everyone, for joining us for this virtual conversation. Thank you a lot, AJ, Christian, and Stephanie, for bearing with us and for exceeding the time slot that was allocated to this conversation. To those of you who are still wondering, yes, the conversation is being recorded and we'll share it online in a couple of days. You may subscribe to our newsletter if you want to receive it directly in your mailbox. Otherwise, stay tuned on our social media to have it. Thanks again for having us, in your calendar, during this day. And please stay tuned for the next panels that will be announced soon. Thanks a lot. So
thank you.
Thank you, everybody.
Thank you so much, Katie, for the great organization and for having us.
My pleasure. Have a great day, all.
Ciao.
Thank you. Bye-bye.